Hello everyone. Today's topic is urine formations. So it is one of the functions of a kidney. How urine is formed. On this video we see how urine is formed. So it is one of the functions in the kidney. So before going to know about how urine is formed, so we have to give a look on the structure of the kidney. Okay, this is kidney. In our body, there are two kidneys are there, one in left side, another in the right side. On the right side, kidney is slightly lower in compared to left one because due to the positions of the liver that is present on the right side. So the kidney it look like a bean like structure, okay, and these pyramid structures are present, that is called medulla. Then outer layer is called the cortex, and the upper top layer, that is the renal capsules. In this renal capsules, fatty tissues are present which protect the delicate organ of the kidneys. Okay, now this medulla, from this is look like it's like stripped structure is in the medulla, that the tubular part of the nephron is there. What is nephron? Nephron is the structural and a functional unit of the kidney. So it is a picture of the nephron. Here the one end is cup like structure, okay, and the other end is attached to the collecting duct. So the cup like, due to the structure just like cup like structure, it is called Bowman capsules. Okay, now this nephron, millions of nephrons are present in each kidney. Okay, their function is to filtrate the ions, water molecules in our body. And from this, after secretions of the essential nutrient the required in body, the rest part excrete in the urine form. Okay, so this nephrons is, millions of nephrons are present in each side of the kidney, and this nephrons the tubular part is present in the medulla, so it is look like straighted. And after the urine formations, after the process filtration takes place in the nephron, then the excrete through the collecting tubes, and the collecting tubes are present here in this area, and this is called a renal pelvis. And from this renal pelvis, it attached to the ureter, and the ureter that connect that take the urine that is formed in the nephron to bladder. Okay, bladder, where the urine is stored in the bladder. It's when the nicotine sensation, the urination sensation is takes place, then it came out by the urethra. Okay, so this is the structure of the kidney. So in the kidney, the renal arteries supply bloods, and again this renal artery makes very small branches, arterioles, and from the arterioles capsules are they create a capsules like the capillary, very thin capillaries are formed. Okay, this is the structure of the kidney. So you have the functions of the kidney. There are three main functions. First is filtration. Second is selective reabsorption. And third one is secretion. Let's discuss the first one, that is filtrations. So in filtration, this filtration takes place in this Bowman capsules. See, it is a nephron. This is the Bowman capsules. The capillary, the scary blood, that is afferent. That carried blood, that is afferent arterioles. It is the part of renal artery that carries blood to the kidney. Here it makes number of branches. Okay, just like capillary structure is formed, that is called glomerulus. Again, the efferent arteriole is there that carry out the filtered the particular substance which are filtered for this glomerular filtrations. That's this substance carried through this efferent arteriole. Efferent arteriole. Why this filtration is called ultrafiltration? Because here in the Bowman's capsule, the epithelial layer of the Bowman's capsule, there is pores are present, and in the glomerulus, the endothelial layer endothelial layer, and between the epithelial layer and the endothelial, that is the basement membrane. Okay, in this basement membrane, the water molecules and glucose, amino salt, the amino acids that can be filtered from this glomerulus to nephron. Okay, but the one exception is that protein is not filtered in the glomerulus. So the protein that is carried out the efferent arterioles again go back to the through this efferent arteriole. So water, salt, glucose, amino acids that are filtered inside the tubules. This is the tubule, come to the tubule, and the rest, like rest of the blood cells and proteins that are carried by the efferent arteriole. Again, these efferent arterioles make numbers of branches. It is look like a network. He is creating a network around the tubules. So it is called peritubular capillaries. Why it is called peritubular? Peri means outer coverage. So this they make a network and cover total the tubules. This is nephron, this is the tubular part, proximal terminal tube, loop of Henle, distal convoluted tube, and finally attached to a duct, collecting duct. So throughout the in the nephron, you see the peritubular capsules are around the tubules. Okay. Then next one is, this is all about the ultrafiltration. Next one is selective absorptions. What is that? Those substance in ultrafiltration, one thing is that that is the blood which comes in by the filtration process. It's filtered to the nephron. So in per minute, the glomerular filtration rate is 120 ml. Okay. So the blood supplied to the through these apparent arterioles, if you see the heart supply blood to different part of the body, so from the cardiac output, it take about 20% of blood that's come to the kidney for purifications. The large amount of blood is come to the kidney. But what happened then in the afferent arteriole by the ultrafiltration, the protein and the blood cells go out, and the rest, water, salt, glucose, they come under the nephron. Okay, so per minute the filtration is 120 ml. Okay, now that is the interesting thing is that if 1 minute is, filtration is 120 ml, so per day it will be 120 ml, 24 into 60, then it will be 170 ml. That is approximately 175 liter per day. Okay, so per day what happens? 175 liter bloods come for the filtrations in this glomerulus. Okay, but how much urine is formed per day? That is 1.5 liter urine is formed. Okay, so in compared to this two number 175 and 1.5, you see it is just 1% of 175 ml, 175 liters per day. Okay, so glomerular filtrations. So what happens in this glomerular filtration? So these substances that absorbed in this tubular part. Okay, the 99% of the substance, solute, ions that are required for our body and water molecules that are absorbed again to the tubules, only rest 1% of the excrete through the urine. That is the daily output of our body. So then it is first part is we understood the ultrafiltration. Then the next one, the selective reabsorption. So what is that? reabsorption. Its name is indicating that this second time absorption is going on. First, then the filtration, the water molecules or glucose that come under the sleeves or the filtration area come to the tubules. Again, these are the essential things. We don't want to lose them. So, these things are again reabsorbed. Okay, these things are again reabsorbed by this peritubular capillary. As I told, the peritubular capillary are present around the tubules. It's make a network. By this selective absorption process, those essential things like water, then sodium, then amino acids, that are again reabsorbed. What? From this tubule to peritubular capillary. Okay. So this is called reabsorptions. Okay. Then in this reabsorptions, first is take place in the this is the glomerulus. The next part I will discuss. Let's the tubule. This is the tubule. The first part is the first convolution is take place here. This is called PCT, proximal convoluted tubule, and this is it's look like a loop like structure, so it is called loop of Henle. And again the another curve is taken, that is distal convoluted tube, distal convoluted tube, and finally this one is the collecting duct. I'm writing as a CD, collecting duct. So, this reabsorption takes place in the PCT, that is proximal convoluted tube. Here, the water molecule and glucose and amino acids that again reabsorb, means from the tubular part to go through this tube, from this nephron to go back to the peritubular capillaries. Again, through this capillary, it's entered to the renal artery. So mostly all the things are reabsorbed in the PCT. Sodium, glucose, amino acids. One thing is that hydrogen ion, that is an exchange between sodium and a hydrogen ion. So if the sodium is going reabsorb, sodium is reabsorbed towards what? Peritubular capillary. But one exception is that the hydrogen ion, that is secretions, that is called secretions, go away, means from this tubular part to tubules. Okay, that is one of the point that is comes under secretion. Later we discuss that one. Then the loop of Henle. Again the loop of Henle, I am going to the tubules, rest of the part. This is narrowing. See this part is narrowing, and again this part is wide. This diameter is very wide, then it is very narrow. So this is as it is going downward, it is named as this descending convoluted tube, and again it is moving up, that is ascending loop of Henle. Sorry, this is descending loop of Henle, that is ascending loop of Henle. In descending loop of Henle, it is only permeable to water molecules, as all the salts are absorbed on the proximal convoluted tube, so it is to maintain their osmolality. So water molecules come in this reabsorb in this descending convoluted tubules, and this area is permeable to only water only, not solute can be permeable through this. And again the ascending loop of Henle, here only the salt particle that is permeable to move, not water molecule. In this ascending convoluted, see the salt like sodium, potassium and chloride that are reabsorbed from the tubules to peritubular capillary. It goes to the peritubular capillaries. Okay, so this is the parting comes, this is the discussion common selective absorption. Then the last one is secretion. What is that? Secretion. After the two process, ultrafiltrations and the selective, some of the few waste particles are present still in our urine, that is not required in our body. Okay, that must be excrete. So the excretion of these particles like urea and some part of sodium that also come in urine. If you take any drugs, these drugs also these which are under the metabolism process, the excess drugs that maybe comes through the urine that excrete from the body. Okay, urea, uric acid, that also excrete through the body. That takes place in the distal convoluted tubules. Mostly the secretion takes place in the distal convoluted tube. Here what happens in tubules, that the secretion takes from the peritubular, here from the peritubular towards the nephron. What from this peritubular capillaries to move towards the nephron or the tubule, so that it's easily excrete through the collecting ducts and finally it's from the urine. So in distal convoluted tube, which rings are secreted from this from our peritubular capillary, that is sodium and potassium. Okay, and some of the drugs that is we taking in the for amoxicillins etc. That's residual part must become in the urine. So finally the waste products that are not required to our body, it's go from by the process of secretions from the peritubular capillary to the tubules, and finally it's attached to the collecting duct. Collecting ducts that collect the urine. Okay, so the amount of urine collection is 1.5 liters per day. But if you see the glomerular filtration rate per minute is 120 ml. So the 90%. So if we multiply this 24 hours with 60 minutes, we get 175 liters per day. But this 175 liters and but excretion in urine form is 1.5 liter. So already it is just 1%. So 99% of the absorption like water, ions that are essential our body is absorbed in this tubule. So this is all about the urine formations. I hope you like this video. Please subscribe my channel.